Welcome back to React Comprehensive Crash Course. In this particular section, we are going to look at structs. Now, structs in Rust are a way of grouping related data together into a meaningful package. They are similar to structs in other languages like C if you've done before, but with more powerful features such as methods. And we're going to cover those too. Structs are used to create custom data types. Now, defining and instantiating structs, that's the first we'll look at. To define a struct, you use the struct keyword followed by the name of the struct and the block containing all the fields for that particular struct. Let's look at a basic example. What I'm going to do is I'm going to go inside here and create, I can probably create it outside. I can say struct user. This is how you can create a structure. And for this user, now if I want to give all the fields, I'm going to say, let's see, user has a username, which is of the type string. Next, it has an email, which is of the type string again. We have, let's say, sign in count of how many times the user has signed in, and I'm going to say that is unsigned 64. And is the user active? For that I will use boolean if it's true or false. So this is how you can create. To use a struct after defining it, you create an instance of that struct by specifying concrete values for each of the fields. So for example, let's create an instance of this. I can say let user, let's give a variable, instance variable user1, and then I can say user, and then I can pass it values like email is, we give colon, and then say it's a string. So I'm going to say string from someone at example.com. Let's give a random email. Next, I want to give a username. So I'm going to say username is again string from, let's say, someone user. So that's the username. Next, I can say is the user active, is true. It doesn't matter the order in which you give, it just matters the key value pairs. And sign in count, how many times has this user signed in? One time. That's how you can create a user with values passed based on a struct defined that you've done. Now you can create mutable structs. So this is by default, as you know, it's immutable. Now if you want to create a mutable struct, what you have to do is you have to assign mute in front of it, just like any other variable. So now it's a mutable struct. Now Rust does not allow marking only certain fields as mutable inside. So everything, the entire struct becomes mutable. Now I can change this by saying user1 dot email. I want to change its email string from, and I'm going to say another at example.com. So this way, now I've initially assigned it someone at example, but now I'm mutating it to another at example.com. So this is how you can create mutable structs. Next thing is field initialization shorthand when variables and fields have the same name. So for example, if I have a function which says that build underscore user, and it's passing me email, which is a string, and username, which is a string, and this function returns back a user. Oops. Back a user. So in this case, if I want to create a user object, and if you see the email is same as this, so when the variable's name from which you're creating a struct instance and the struct's field names are same, you can use the shorthand initialization syntax. For example, I can say user, can say email. I don't have to do anything else. I just say email. So it automatically assigns email to email. Username active. Now there's no value for active, so I'm going to pass active is true, and then I'll say sign in count equal to 1. So this is how you can do a shorthand initialization. Next thing that I want to show is struct update syntax. You can create a new instance of a struct based on existing instance with the struct update syntax, which is dot dot. So for example, from this user one, I want to create a user 2, and pretty much everything I want is same. So what I'm going to do is I'm going to say email string from, I'm gonna say some email at example.com. So this is the email that I'm giving, but I want the rest of the fields to be same, so I can just say user1. So what it will do is this syntax makes like user2 have the same values for username, active, sign in count as user1, but it gives a new email for this particular user. uh, Next thing we're going to look at is tuple structs. Now we looked at tuples. So now tuple structs are similar to tuples, and they are useful when you want to give the whole tuple a name and add meaning to the elements. But you don't need to name each element individually. What do I mean by that? So for example, I can create struct, say color, and it has I32. I32. This is the tuple styles I32, and I can create something similar for, let's say, a point in value I32, I32, I32. Now when I create an object, I can say let black equal to, I can just say use that struct color, and I can say 0 comma 0 comma 0. So this is how you can make like color hex structs. And similarly for points, I'm going to say like point in screen, you can just assign this point and give it values over here and use that for use it as a struct. Next thing that we can look at is unit like structs. Unit like structs do not have any fields and are useful in situations where you need to implement a trait on some type but don't have any data to store in the type itself. Now we are not looked at traits or enums in particularly, but we'll probably look at them next. But for now, let's say always I create a struct called as always equal, and then I just want to assign it to something. So always equal. So in this case, you'll probably see like you do not have any fields and are useful in situations where you need to implement a trait on some. So that's how you do it. That's unit like structs. Now I mentioned about methods. Structs have methods in here. Now methods are functions that are defined within the context of a struct or an enum or a trait object. As I mentioned, in enum and traits, we're going to look at it later. But for now, let's say in a struct, and these are called on instances of that struct. Now let's say for this particular user, we have, this is the struct. Now I want to implement user methods. So inside this, I'm going to say there's a function called as email and self. So this is how you pass the self object, and it returns back string address by doing inside here, I'm going to say dot self dot email. So this method takes an immutable reference to the self. So this is how you pass the reference to self. In many programming languages, you've probably also seen you don't pass the actual object, but you pass the reference. So you're passing the address where that object includes, uh, and it returns back a reference to the email field. So it gives back a reference to the email field, which is of the type reference string. So that's what happens here. This is how you define methods. Now, there's also associated functions. Associated functions are functions that are associated with the struct but don't take self as a parameter. So, for example, I can say implement user, and inside that, I can say function, let's say new, so associated, and inside that, I have email passed as an object string. So these are often used as constructors. So if you're familiar with that, you'll probably understand what I'm doing. So it kind of creates something where it has some values in a particular order. You can call the function. So inside here, I'm going to say for user, since the names are same, I'm going to say email, username, active equal to true, and then sign in count equal to 1. Just give it some values here because it just calls this thing. Now to call it, what you can call this associative function using the colon colon syntax. For example, I can say let user1 equal to user, and say new, call that function. Inside that I can pass string, from, I pass x at email.com, some random name, and then similarly for the next one, which is the username field, I'm going to do the same thing. I'm going to say a string from xyz. That's the username. So if in here you'll see like I used double colon to call this associated function, and that's how this works. Now structs are a fundamental feature in Rust, allowing you to structure related data together. By understanding how to define, instantiate, and use structs along with their methods and associated functions, you can create complex and meaningful types in your Rust programs. The use of structs is crucial for creating well organized, modular, and reusable code, as you can see. So, if you want, we'll probably work on it quite a lot when we build our own examples and the projects. You'll probably see that in those videos. But this is how you create structs. If you have any questions, please leave them in the comments. Thank you.